Today we're going to look at the second day of nonlinear systems. All right, just 2 examples today, so nothing crazy. Solve the systems algebraically and graphically. You can see here we graphed it. So this red and black graph is the x squared plus y squared equals 40, and then the blue line is the linear equation x minus y equals 4. So to start, we're going to use some substitution. So I'm going to solve the second equation for y. So we will get y equals x minus 4 if we do that. Since that's what y equals, we're going to plug that in for y into the other equation. X squared plus x minus 4 quantity squared equals 40. And then we square out that squared binomial there. X squared plus x squared, what would that be, minus 8x plus 16 equals 40. So we get 2x squared minus 8x, and then if we do 16 minus 40, we get a negative 24 equals 0. Now we have a quadratic. The coefficients and constant are all divisible by 2, so we're going to divide everything by 2 so we can have a leading coefficient of just 1. So if we divide everything by 2, we get x squared minus 4x minus 12 equals 0. And this we should be able to factor into x minus 6 times x plus 2. So therefore, 2 possible solutions for x are 6 and negative 2. Now that we have those, we have to plug each of those into one of the original equations. I'm going to use x minus y equals 4. Just seems a little more simple since there's no squared terms. So 6 minus y equals 4. That would mean y would have to equal 2. So one of our solutions is 6, comma 2. And then the other solution is negative 2 minus y equals 4. So that means y would have to equal negative 6. So when x equals negative 2, y is negative 6. So our 2 solutions are 6, 2, and negative 2, 6. So if you look here, this is one of our solutions. That's 6, 2 on the graph. And then negative 2, negative 6 over here. And that you could find by doing on your calculator second calc and then find the intersection. All right, here's our next example. Now, as you can see here, when you graph this one, the graphs don't intersect. So this is going to be an example of something that has no solution. Let's see what that looks like algebraically, though. So similar to the last one, I'm going to solve this second equation for y. So y equals x minus 4. And then from there, we're going to plug that y into the first equation. So x squared plus x minus 4 quantity squared equals 4. It's going to end up looking kind of similar to start. So x squared plus x squared minus 8x plus 16 equals 4. And then from here, we'll get 2x squared minus 8x. And then if we subtract that 4 from both sides, we get plus 12 equals 0. And then the coefficients and the constant are divisible by 2, so we're going to divide everything by 2. So we get x squared minus 4x plus 6 equals 0. And then this one, you end up not being able to factor because the factors of 6 are 1 and 6, 2 and 3, but none of those, even if we include negatives there, are going to add up to be this middle coefficient, negative 4. So this would be an example, can't factor it. So for that quadratic, we would say non-real answer. So that means that this particular system of equations would have no solution. So by the graph, you can tell because they don't intersect at all. And then by the equation, you can tell because you can't end up factoring that out. All right, so that was it for today. Finish up that worksheet 12.5 if you didn't on Friday, and then there is a daily task on Schoology for you.